Alright, enough talking, let's do some examples and make sure you get it. So if I ask you to sketch this graph by hand and give me some of this other information, this should be getting to be relatively easy. So let's look at it and make sure. So what is the degree of this polynomial? It's n. We've got 1x there, so this is x to the 1. We've got x squared, so that's 1, 2, 3, 4, right? We've got an x to the 4th, so the degree is 4. My a sub n, that's my leading coefficient, right, of the highest degree term, it's going to be positive or negative, because that's what I care about for end behavior. It's going to be positive, right? A sub n is greater than 0. My y-intercept, if I plug in x equals 0, what do I get for my y value? Oh, well, that one's nice. 0, right? 0 times 0 minus 4, negative 4 squared times 0 plus, I don't care, it's times 0. Okay. So this y-intercept is 0, 0. Without that term, you get more interesting ones, but for now. Okay, so let's plot the zeros, if we're going to sketch that, that's the next step. The zeros are, well, 0 is a good one, right? Positive 4 and negative 3. So I'll put those on my graph. 0, 2. Alright, let's talk about end behavior. We know the leading coefficient is positive and it's an even degree polynomial, so it's got to go up on both ends. Let's look at what happens in the middle. So at negative 3, what is the multiplicity? What's the multiplicity at x equals negative 3? Multiplicity 1. That means behaves just like any linear function. Y equals x minus 3, it just goes straight through. Okay, now when I get to 0, oh, still multiplicity 1. I'm on this side, so I'm just going to have to come back through it, straight through. At 4, my multiplicity is 2, so let's fill this in, 2. Okay, so at 4, I want it to behave like a quadratic, and now I just have to connect up my graph. Okay, let's try another one. The degree here, start with n. Let's see, we've got x squared, so that's 2, and then 3 more, that's 5. The degree is 5. Our leading coefficient, if we multiplied all of this out, would be negative. So a sub n is less than 0. Our y-intercept, again, plug in 0. So f of 0 is negative 25 times negative 1, so f of 0 should be positive 25. Okay. 0, 25. Now, I don't care about my scale on my y-axis, so I'm just going to put that on there, and everything else, not going to worry about it. That keyword is sketch. Okay, now let's look at the zeros. They are negative 5 and positive 1. So negative 5 has a multiplicity of 2, and 1 has a multiplicity of 3. So this one is going to bounce off, and this one is going to have a point of inflection. Okay, so let's look at negative 5. I know the graph is going to bounce off, but is it going to bounce from the bottom or from the top? Well, that depends on the end behavior, because there are no other roots past that point. So a sub n is less than 0, and it's odd. So normally odd functions do this. If it's negative, upside down. So it'll come out of here like this, and it'll come out of its last 0 on the right, going down. Okay, 1. Okay, so at negative 5, the multiplicity is 2. Let's make it bounce. Now, I have no more zeros here, So I know it's just going to climb up and come through 25. I don't know if 25 is the highest point. I don't know if it's on the way down or if it's on the way up, but I don't really care because it's a sketch and I haven't asked you for the extrema. I don't care where the maxes and the mins are. I only right now care about the zeros, the y-intercept, and what it's doing at all of its zeros. Okay, so I'll come down at 1. It should come through here, right? But does it go straight through? No, it shouldn't be straight at that point. So let me clean this up a little bit. It's going to come down and squiggle right there, have a point of inflection, and then go down. It doesn't have to go all the way flat here so that its slope is 0. That's not necessary. It just has to squiggle a little instead of going straight through. Okay? This is the place where it goes from concave up to concave down. Alright, enough with the graphs already, right? Let's do some actual algebra. Woo! No? It was worth a shot. Okay, so sometimes you don't actually want factored form, sometimes you do want standard form, and sometimes you have to do lots and lots of multiplication to get there. So here's where we just multiply to our heart's content. I'm going to leave this x until last. I'm going to deal with the squared terms first because I can do the squaring pretty easily in my head. Alright, leaving me x plus 3. This one, x squared minus 4x, and 4x is 8x plus 16. Okay, now I distribute slowly and painfully. X times x squared, x cubed, x times 8x. Okay, then distribute the 3. Okay, combining like terms, negative 8x squared and negative 3x squared, negative 5x squared, x's minus 8x. Constant, and then last, distribute this x through. X to the 4th, 5x to the 3rd, minus 8x squared, plus 48x. Alright, my sultan has woken up, so I need to speed this along. We're going to find a cubic equation with the zeros 3, 2 plus root 2, and 2 minus root 2. And the hidden direction is in here that I don't just want factored form, you have to put it into standard form, which is absolutely a pain. I understand you can suffer with the generations that have come before you. So, here we go. F of x is equal to, okay, for that to be a root, for 3 to be a root, I have to have x plus 3 or x minus 3. I think you said x minus 3, so that's good. I want it to be cubic, so it's got to have we already know 3 roots, so they all have to be multiplicity 1. So at least I don't have to square anything. Alright. X minus, I've got to put 2 plus root 2 as the root. But if I do this, I'm not distributing this negative. So, you're going to have to use brackets. I know, you don't like them, do you? And in here, we'll have, okay. And again, for this one, x minus 2 minus root 2. X minus 3, let's get rid of the brackets and distribute some negatives. X minus 2 minus root 2. X minus 2 plus root 2. Okay. Now, this is the simplest, leave that for the last. Let's do this first. X times x, x squared. x times negative 2 minus 2x times this. Negative 2 times x, negative 2 times negative 2, positive 4, negative 2 times root 2, okay, that's a mess. Now we have to cancel some things. But the good news is, lots of stuff's going to cancel. We've got a positive x root 2, we've got a negative x root 2. We have a negative 2 root 2 and a positive 2 root 2. X minus 3 times x squared. We've got 2 of those, so negative 4x. 4 minus 2 is 2. Alright, well that's not so bad. X cubed minus 4x squared plus 2x. And your final answer, x cubed minus 7x squared plus 14x minus 6. That function has the zeros 3, 2 plus root 2, and 2 minus root 2. Whew. That's it. Do you know why pirates don't have to worry about being hungry if they're stranded on a desert island? It's because of all the sandwiches there. Was that a thank you? Can you wave bye-bye to the camera? Bye-bye.